Right, so let's have a look at using first principles to find the derivative when we've got a square root. The formula hasn't changed because, once again, we do not have a point. So we're going to use this formula, right? And we follow the same rules. So wherever x is in the function, we're going to replace it with x plus h. So instead of the square root of x, it's the square root of x plus h. Okay, and minus our function, which is root x. And there we go. Now, our game plan, as we've said before with all of these questions, we want to cancel out the h, because as soon as we do, we can make it equal to 0 and away we go. We can't do that now because we don't want to divide by 0. That's going to get us in all sorts of bother. The problem is, if we look at the top line, we can't really cancel anything because of these square roots. So how do we get rid of a square root? Normally we would square, but in this case what we have to do is multiply by the conjugate. Okay, so we're going to multiply by the square root of x plus h plus root x, because that uses our difference of two squares, and the middle term will disappear and the end terms will be squared, so hence the square root will go. And of course what we do to the top, to the numerator, we must do to the denominator. So let's have a look how that pans out. Always write your limit, right? Don't forget to do that. That's all about notation and what we're doing. So root x plus h times root x plus h is root x plus h squared, which is just x plus h. Okay, then we go root x plus h times root x, but then I've got another minus root x times root x plus h, and they cancel each other out. Oh, difference of two squares, thank you very much, conjugate. All right, and then we've got minus root x times root x, which gives me minus x. Okay, downstairs we will have, the root x plus h plus root x. That's your downstairs, but remember we are timesing that by the h. Okay, now if we're looking at the top line, you'll see some things cancel out. So we've got the x minus x, that cancels out, and then we can divide the h by h. So that cancels, and we're left with 1 over root x plus h plus root x. And now we get to make now we get to make h equal to 0, and therefore we end up with 1 over root x. I'll write it just so you can see it, root x, because we no longer have this h, that's gone. It's another root x, so we're left with 1 over 2 root x. So f dashed of x equals 1 over 2 root x, which if you really want to, you could rewrite as half x to the minus a half. And if you then go and apply your shortcut rules, right, to that function, you'll see that that is the function that you get. Let's have a look at the next one. Okay, so do it on the other page here, downstairs. Once again, write your formula. Just pause. Okay, pre-drew my limits in. So the first step is, it's the most important. If you get that right, all is well. If you stuff it up, it's a long time to find your error sometimes. Okay, so wherever the x is here, we're going to replace it with x plus h. So it becomes 2 times x plus h plus 1, still underneath the square root, minus f of x, which is 2x plus 1, all over h. Okay, so just like before, we want to get rid of the square roots, and the only way that we can do that is to multiply by the conjugate. Okay, so now you see why I had to do it downstairs and not in the other side of the page, because I wouldn't have enough room. Okay, that's a minus, so we're going to pop a plus there. So that creates our difference of two squares when we're multiplying, and hence we get rid of our square roots and get what we do to the top, we must do to the bottom. You know, I'm not even bothering to expand the brackets here because I know what's going to happen is I'm eventually going to just replace that h with 0. Okay, that's the whole plan of this. So here we go. When I multiply this square root by this square root, okay, the roots disappear. So I'm left with 2x plus h plus 1. And then you multiply that by that, but of course that cancels out with that one underneath. Whole point of what we're doing. And then the last one, root 2x plus 1 times root 2x plus 1. Don't make the error by just saying minus 2x plus 1 here, because obviously we're subtracting the whole thing. So make sure you pop it in the bracket. And then underneath our denominator, we've got 2x plus h plus 1, right, plus root 2x plus 1. We're multiplying all of that by h. All right, so let's see what happens. Might as well expand the bracket before we look at cancelling. So we've got 2x plus 2h plus 1 minus 2x. Take 2. Actually, I might just give you a bit of space so you can see it. Okay, so just gave that a little bit of room. It's better to spread things out rather than to keep them all squishy. All right, look at that, I forgot my bracket there. Plus root 2x plus 1. Okay, remember we want to try and have a common factor of h on the top line, so anything that doesn't have an h should have disappeared. So yep, 2x, you get the minus 2x. If you hadn't used your brackets upstairs, you would have had 1 plus 1, and that should have alerted you that something is amok. So let's go back and find out where. It's always those brackets. All right, so on the top line now, I've got 2h all over h bracket 2x plus h plus 1 plus 2x plus 1. And of course, you should see where this is going now. The h will cancel, and now we make h equal to 0. So I get f dashed of x equals, I've got 2 upstairs, and then downstairs this h is now 0, so that's gone. So I've got 2x plus 1 plus another root 2x plus 1, which ends up being 2 root 2x plus 1, which can cancel to be 1 over root 2x plus 1. There you have it. But it's all about, whenever you've got the square root, what's the trick? It's the conjugate. Okay, so make sure you're neat, clear, and you multiply by the conjugate. Hope that helps.